Okay, thank you. This presentation is related to the previous one. Also, it's about some estimation issues. So I wonder you found it interesting. So the title is validation of supplier estimates using the COSMIC method. Again, we naturally use COSMIC because it's a national norm, but we see at the end that maybe it could be applied in another functional size methods. The agenda are three main points. The first one is the main research approach, but what is the main research approach in estimation in software projects? We talk a little bit about it. Then we're going to see what is the difference and what we are referring as a validation estimate model. Okay, this is the proposal. And then I'm going to show you a case study in the Mexican industry. Okay, the first is this is about the estimation in software projects. A little bit related with the previous presentation. No, the issue here is that it's well known that the organizations, software development organizations, need better and formal methods, estimation methods. The idea, of course, is increase the rate of success projects. Currently, the success projects in software is not good enough. According to the standards group, is less than 30%. So, well, this CAO report is for the 2015. I don't know the new ones, but it's around 30% maybe. So there is a need to improve the estimation methods. So what is the estimation context? In the estimation context, we have usually two parts, the customer and the supplier. The customer requires software development. Let me minimize. Okay. The customer requires software to accomplish their needs in order to implement some strategies. So they get some needs, they get some requirements definition, as the previous presentation mentioned also about the scope. Then they need to make an estimation. The estimation for the project to be developed usually is delegated to the supplier. The supplier could be internal. The supplier could be internal or external. Okay, internal is a internal capacity of development of software, maybe a people or a group of people or a team or whatever, or maybe an outsourcing supplier. So anyway, the supplier usually use a process or method to estimate that could be reduced in a simple manner, as is mentioned in the book of Alain, or by expert judgment and using a mathematical model. Okay, most of the cases, at least in Mexico, are using expert judgment. After the supplier provides or generates the estimation, in the previous presentation, they are using, I assume, a mathematical model, then generate an estimation. The estimation is delivered to the customer. This is the context of estimation. After the estimation begin the project development. No? Okay, the validation of the estimation, the planning, and the project execution. Okay, in this context, usually in the literature, most of the techniques or models that have been developed to estimate are trying to tackle the point of view of the supplier. I mean, you need some elements to estimate the effort to take that this part of the equation, the effort that this part of the equation requires to develop the software. Could be the effort, could be the cost, and whatever. But considering that this is the supplier and this is an outside company, maybe the information they know is different than the information that the customer know. In fact, we have been write something in 2013 about information asymmetry. So there is different information about between supplier and customer. Okay. So estimation from the perspective of the customer has not been really tackled in the literature. So it's important to make a difference. The difference is the supplier, internal or external, need to implement a formal estimation process. In the formal estimation process, there are some steps, no, that require a reference database, formal measurements, and whatever. So they need to develop a productivity models, evaluate confidence estimation, define some ranges as the previous presentation mentioned, identify some risk and whatever. And after all, they have some kind of information related of how many effort we need to develop the software. But how many effort is not a number. It could be a range of effort or a range of cost or a range of whatever about the estimation that the supplier does. So after that range of information, the estimation could be in this range, the minimal and the maximal of the range, then became an important part that is a manager. The manager role will use this range to define a price. I mean, they're going to consider contingency funds and define a budget. This budget is to be provided to the customer. So we have, or we need to consider that in the estimation process, we have two parts. One is the supplier part, and the other is the customer part. If we see this information, we understand that in the cost budgeting, we have some information related to functional size. We used to convert using some factor to determine the cost. But there are other elements like non-functional requirements or some constraints. So the cost, the project cost is determined by the manager, not by the people related to the technical estimation. So the technical estimation is one part of all the cost budgeting. And there is a specific and very formal, a very important part for the estimation. But there is not the estimation, indeed, there is not the main issue for the customer. So what is the difference with the validation, or the point with the validation estimates? In one side, as we mentioned, we have how the supplier need to estimate the effort to develop a software. Okay, this is one part that we cannot avoid, because the supplier always need to estimate how many effort they're going to take to do the software that is required. On the other hand, we have the customer. Once we have the estimation for the supplier and provide the estimation to the customer need to evaluate and validate that estimation. The problem is how the customer validate the estimations, because the customer doesn't know how the supplier generates the estimation. What is the relation between customer and supplier? Need to be something units, measurement units. That should be measurement units. Well, in the previous presentation, we talk about the scope. The scope could be something that the customer could understand and the supplier could understand. And the scope could be measured using units like cosmic or some functional size methods. So, but at the end, the customer doesn't have information that the suppliers use to make their estimation. So the naturally form they validate the estimations is using expert judgment. But the expert judgment is not very formal and present several problems, okay? So we need to improve this part. But if if we are talking here, we have most of the literature research are related to this part from the supplier perspective, not to the customer. So what is the difference between estimation model against validation model? If we see in the general form of an estimation model is a relation between size and effort, for example. This could be also maybe a cost. But at the end, we try to find a correlation between size and effort, okay? So this model is created with a reference database for a specific client. In the previous talk that I give to you, I mentioned about the Mexican reference database. With that Mexican reference database, we can build some estimation model like this. Okay, so we have a set of projects, of data projects, and then we can construct an estimation model. But if I am a software development factory, for example, or software development company, I have the effort related to how I work to develop my projects. This information is not public information. No one other software factory knows that information. It's useful for me, and I have this information for my own use. So the difference is with the estimation model, we need to define the effort, or we need, or I try to predict the effort to build the software. Okay, considering a range of values. Okay, but this is from the perspective for the software development company. On the other hand, what is the difference with the validation model? Once we provide the estimation, the customer needs to validate the estimation. So if we see here, we have a one supplier or second supplier. With their own historical database, they build the estimation model. With this estimation model, they provide some value for the customer. But the customer could have this supplier or this one or other suppliers over the history. So they could build their local database. But this database is related to the business functions. I mean, Alain mentions in the iceberg analogy the label of requirements. If we use the function labels, we are at the highest level, the part that above the water. Okay, so the customer knows that. I mean, know the scope at this level. They don't know the scope from below the water. So the customer needs to build their own database, local database, and the input for the suppliers need to be evaluated in the local database. I mean, the suppliers know his own data that could be different, and they, to provide an estimation, they could add the profit and also the contingency fund and some other elements. But this is not known by the customer. The customer only get one data. This data should be evaluated with the reference database. So we have different database then, the different reference database. One reference from the perspective of the customer that need to be used to validate the estimation that is provided by the suppliers. Then the customer could be analyzed and defined if some estimation could be very expensive or very cheap, or have a specific probability against their own database. So this is important because usually, at least in Mexico, we have seen that the customer tried to know precisely how the supplier are making the estimation, and there have no sense. I mean, the only element that is needed is the scope. The scope should be known by this one and by this one. With this scope, the supplier needs to put a price, or need to put an estimation, or need to define an effort. But the customer needs to be able to validate which estimation is better, considering their own database. So I mentioned this in the previous conference, so I'm not going to spend too much time in here, because the result from here is that we have now a reference database. A reference database meaning from the business function perspective. That means from the customer perspective. As Alain mentioned, this customer's perspective, I mean, one functional size, one cosmic function point, for example, of or one functional size unit at this label, the functional size label, maybe could be decomposed or increase over the composition of the in the considering the iceberg model. Maybe this single functional cosmic functional size at the business function could be converted in 10 or maybe 30 cosmic function points, but in the lower label. But the estimation need to be made and need to be done at the first label, not at the end of the label, because you know the end of the label during the project, maybe at the end of the project. So the estimation as is previous, we need to use the scope at the business function label, as mentioned by Alain. So this is the important part. So the Mexican reference database is built from the business function perspective. That is why it could be used as a reference for the Mexican industry. We don't know exactly, at least we can try to figure it out using the iceberg model, how will be the total functionality from the lower labels. But there is no meaning if you are using this just for validate the estimation, because the part of the iceberg above the water is what you know at the beginning in the project. After we build the database, we use the perspective of the customer, as I have mentioned. This is the data in our Mexican database. The blue part is the interval density. The orange is the density function that is derived by intervals. And if we see in this part, in the other graph, we could see the same intervals, and we tried to match the density function derived by the intervals with the log normal density function, because it's very easy. The log normal density function match almost perfect with the density function. So with this first step, we identify that in the density function, we know that represent 100% of probability that for the projects. That means if we consider all the area below the curve represent the total of the probability for the projects, and each range represent a specific probability point. So using the log normal is very interesting density function, because could be mapped to a normal function. This is the log normal function, and with the logarithmic or exponential, whatever, we can convert to a normal. So there are important elements related to the log normal function or the normal density function. For example, we have the mean, that correspond to this point, and also with this. In the log normal is called geometric mean. But there is also that minus sigma 1, this point, that could be recorded to this one, okay? Why this is important? Because as we know, we can observe the increasing of probability moving from one part to another. So, for example, in this minus sigma 3, we have 0.1% here. Oops, sorry. In minus 2 sigma, we have 2.3 because it's 2.1 plus 0.1 is 2.3 because the rounding issues. Okay, so at the geometric mean we have 50% of probability, and so on. So if we have in the database that the behavior of the projects could be represented by this log normal, we could identify the probability of the projects to be completed using the historic database. So once we have characterized the behavior of the projects in the Mexican database, we go to with the customers and we ask them to define quality criteria. These quality criteria are defined considering the probability they expect to be success for the estimations in the project. Of course, if we are, you can expect you could be interesting to guarantee the highest probability to be success in the project. However, to guarantee this kind of probability, the cost could be very high or very expensive. On the other hand, we can expect a very low probability with a very low price. So we need to identify a good range at good point, considering the risk for the customer they need to assume. So we know here, until now that, as I previously mentioned, that the probability in the software projects is less than 30%. So what we recommend to these, to our customers sometimes is to define some probability according that they expect. In this case, they use 64.4% to 84.1. That means they are expecting from the expected value to the plus sigma 1. That means they are considering expected value from, okay, we have no sigma 1 here, but maybe it could be like this, okay? So they are expecting this kind of probability, or maybe around here, this probability, okay? That this probability higher than 64% and less than 84% is higher than 30%. So they select this range, but that could be another range. In fact, you could be defined several range or as we call quality criteria, depending of the projects or the specific type of projects. For example, you need more precision, or you need more probability to be success for a electronic transfer project than a telephone directory project, for example. Okay, so this criteria could be defined according to the needs of the for the customer. There is no specific or constraint or rigid fixed criteria. You can modify this validation criteria according to your needs. So the case study. Once we have been developed this, we have. I mean, this in the previous conference, I talked about the database. Then we are using elements to validate the estimations. All these steps we have been used several years in the Mexican industry since 2015. So in particularly in 2018, we use this approach for validation estimate in Mexican entity. Okay, in this entity, 9 projects were developed. In this case study, we are using as a shadow case study. I mean, they are using the ways they used to estimate and wherever and take decisions. But as a shadow, we carry out this case study. So the amount of the contract was this one in US dollars, approximately, for 12 months. Okay. The contract operation, the customer requests the projects to be the supplier for the supplier. The supplier provides the estimation, as we mentioned previously. And usually they use effort estimation, and then the customer validates the estimation. Okay. We use EPCU approximation because we have been demonstrate in several studies and in a practical way with a lot of projects to be used, that the variation from the approximation estimates using EPCU with the measurement is not too high, and using the EPCU approximation is very fast. So additionally, we also have been developed a tool that implements, so it's very easy, as was mentioned in the previous conference. So with that estimation from the project in effort and with the size, we determine the product delivery rate. With that product delivery rate, we try to evaluate considering the quality criteria definition. This is the resume for the 9 projects. Here we have the projects, okay? This is the number of elements, requirements elements. Some of the projects use use cases, some other use functional process. This is the total effort estimated by the supplier. This is the functional size or the approximated functional size. And then this is the PDR. How many hours by cosmic function point, considering this and this one. Okay, so considering the validation criteria, we only identify 2 projects, this one and this one, that accomplish the validation criteria. All the other projects do not accomplish the validation criteria. Look at this project. These not accomplish the validation criteria even when they have 90% of probability to be success. Why do not accomplish the validation criteria? Because the validation criteria is defined considering the perspective of the customer trying to reach a good price. In fact, we have projects in Mexico that have very high PDRs, in unbelievable PDRs. Yeah? For example, there is a company that use in government entities a PDR about 84 hours by cosmic function point. It's incredible. It's incredible. It's not. It's a natural outlier. Okay. So, but when the customer does not have this kind of information, they don't know if that PDR is out of the scope. So there are other projects that don't pass the validation criteria because it's less than 64%. So graphically, how can we see this information? We have the validation criteria is defined here. So there are only 2 projects inside the box. There is 1 project outside the box. That means is overestimated. Let me say that. And then we have 6 projects below the validation criteria box. Okay. Okay. Then we identify that these are associated with some specific productive probabilities that are defined here. Then this is how graphically we can see the information. were the case study results. Theoretical decision. Theoretical decision using the validation model that we proposed. We expect that the 6 projects below the minimal value for the validation criteria were rejected. Okay, this is the theoretical decision. For the 2 projects inside the box, of course, they could be accepted. And the project outside the box, for the right, I mean overestimated, did need to be rejected or at least renegotiate with the customer, because there could be some element that the size is not correctly, for example. They see something different. The real results. I mentioned the theoretical result because, as I mentioned, it was developed as a shadow. Okay, they follow the process they usually do to accept the project. So all the projects were accepted as the supplier give the estimation. I mean, all were accepted, but the theoretical decision should be the customer should be reject 7 projects. The real result is from the first 6 projects, 4 of them during the project make a lot or at least one change request. The change request, what was made, try to increase the effort and to finish the project. This is important because in the theoretical decision, you should be identified that there is a very low probability to be success. So the renegotiation should be done before the project was in execution. The other 2 projects, the cost was assumed by the supplier, okay? For these projects, they have no problem, okay? The projects were executed correctly and all. And for the last project, the supplier reports the consumption of all the effort. So we assume that was correct, but the problem is that we do not have a way to validate if they really use all the effort. And this is an additional problem that is called moral risk, that is determined by information asymmetry of information. Asymmetry of information or information asymmetry in economics are the creator of 2 problems: the moral risk and the adverse selection. So we have no idea how to validate this. We have no idea how to validate this. We are not able to see if they use all the effort, but was reported that was used. So the threats of validity of this this proposal. We are using COSMIC, okay? We are using COSMIC because it's a national standard. However, as Pierre mentioned after my first presentation, a good idea is to measure in a standardized way. So if this validation model process could be used with other functional size measurement methods. I mean, I think there is no problem. The main issue is to get enough information. We are assumed here that the supplier and the customer use the same functional size measurement method, as looking this element as the understanding element. If they use the same functional size method, could be easy to implement this type of validation models, because the functional size measurement methods represent the scope. So the scope is the element that needs to be known by the supplier and by the customer. If they are familiar and agree with this scope, the validation and the estimation and then the validation for the estimation that provides the supplier could be easier. In the practice, we have been note that when they are using the same functional size unit, you could identify very early in the phase of the project that in some cases, the customer and the supplier are looking different scope. So this is very important because they could help to align the same scope, to define the same scope that could be understood by the two sides, sizes. Here we only use the shadow mode. I mean, we need at this time, in the moment when this case study was created, we used only at the shadow mode. However, we promote here that we need to make some more research about it. 2 years after, right now, we have been implemented in several projects and with good results. The conclusion. The validation estimate model was based in a log normal density function because it's the function that looks more similar to the reality of the projects in the Mexican database. The validation criteria was defined using these probabilities to be success in the estimation. A relevant issue is that with this validation proposal, you could consider disqualifiers to underestimation or to overestimation. This is important because some issues that we have seen in the industry is that, like in this case study, there is a project that is overestimated. There is a lot of project that is underestimated, and at the end, the average of all those projects make that the supplier gets some kind of profit, but it's not the optimal for the profit, and for the customer there is a very high risk because all the projects that were underestimated, at the end the customer has the problem that this kind of project require more budget, more effort to complete, and they need to be complete to implement the strategies defined previously. The idea of the use of this model could avoid the problems for the projects in the project's execution, and could also help to save resource for the customer. If you have a good estimation at the beginning, you should take a good decisions in order to try to implement a project or no. If the supplier provides you an estimation with a very low quality, you need to know that maybe during the project or after the project, you need to invest more money, invest more effort to finish the project. This information is also done, these kind of models and all this information, we are also the approximation we use with the Mensura tool. So all this stuff about the validation estimation and also the use of approximation approach, it could be done at Mensura tool. I think this is all that I have for the validation estimation model from the perspective of the customer. So I am open to the questions. I wonder if it was a little bit clear, my presentation, and I'm open to your questions. Thank you.
So we have a question.
Thank you, Francisco. Yeah, we have a question here.
Yeah, does the validation model apply to any type of recalibration, or does the validation model apply any type of recalibration based on actual data when projects are finished?
Yes, we usually in we mentioned this tool. In this tool, we have implement something that we call Software Accountability Office. The Software Accountability Office is something that defines several processes related to the estimation. in the estimation that we have been, in the estimation process that we have been defined, the recalibration is automatically in the, because when the project is end, this project is considering as in the reference database. So yes, it is considered the recalibration for the ending finished projects.
Okay.